Hey, welcome to Unit 23, Congruent and Similar Figures. I will be your host through this COVID virtual unit, which will be Unit 23, and then I'll do one for 24, and then we'll hit circles, which will be the unit for this week. I can't remember if I let you guys know or not, but I'm under house quarantine until Friday. I can't be out or anything. I went and got myself exposed to the COVID, not knowingly, but did happen. So, yeah, we're going to do this. And then no test this week, just work on 23, 24, and 25. And then next week, we'll do a catch up test, but we'll review questions that you have beforehand, make sure you're comfortable with everything, and then go from there. All right, so congruent figures have exactly the same size and shape. They are given by a squiggle over an equal sign, okay? Congruents, they're exactly the same sides, and they have corresponding sides and exactly the same angles and corresponding angles. So let's see what that looks like. So angle C, angle F, angle E, angle B, angle A, angle D. All right, those are corresponding angles, exactly the same. And we have corresponding sides. Okay, 2.1, 2.1, so that'd be PM and TR. PN, 2.6, TS, 2.6, MN, 1.8, RS, 1.8. So now we have corresponding sides that are exactly the same. And that's exactly what that says. Great. Similar figures are just that. They're similar. The shape will be the same, but the size is going to be different, and the angles will be the same. So this one squiggle means similar, okay? Similar but not the same. And it says corresponding angles of similar polygons are equal, but corresponding sides of similar polygons are proportional, just like I said. So we look at their perimeter. So let's look at this. CB and big CB correspond to each other. EF and EF correspond to each other. And we're going to publish this real quick. Yeah, so continuing, yeah, these are corresponding sides, all right? So, and they can be set up as proportions, and that's really, really important. So, right here, so we've got AB, big AB, BC over big BC, CD over big CD, and so on, okay? So, because we have proportions, if we're given three pieces of information, so if I know what this is, and this is, so this is, yeah, and then this, I could find out what this is as well. All right. So let's take a look at that and see how that works. All right. So we're given information. It says AB right here is 9.1 centimeters, and big AB is 10.5. Don't know why I just did that. ENF over here is 5.2. It wants to know what big E and F are. So we set up a proportion. All right. It's straightforward, pretty simple. We go ahead and say, see, we're looking for big E and F. So I'm going to make E and F X just for ease. And I'm going to put that over the 10.5. All right. And that's going to be equal to, let's see, 5.2. And notice how I have the corresponding sides in the same position, okay, over the 9.1. Again, corresponding sides in the same position. So I'm going to bring that up, multiply 5.2 by 10.5, and divide it by 9.1. So that's going to now look like 10.5 times 5.2 over 9.1. And when we do the math, and let's do the math. So 10.5 times 5.2 divided by 9.1. And our answer is 6 centimeters. All right. So it's 6 centimeters. Let's see what they did. Set proportion the same way. Well, they did it on top. You'll notice that 9.1, these two are on top instead of the bottom way I did it. I always like to put what I'm looking for on top. It's just easier because that way you're just bringing one thing over. Because in this case, it still works. You have to bring 9.1 down there, take E and F up to the other side, and then it's just an extra step. Like, and I'm all about not doing extra steps if I don't have to. See, and still ends up like that. 6 centimeters. There you go. Similar triangles. This is kind of a cool rule. It says if two angles of a triangle are equal to two angles of another triangle, these triangles are similar. The corresponding sides of the two triangles are proportional. The triangles are similar. And if two sides of a triangle are proportional to two sides of another triangle, yes, they're similar. Yes, beat that horse. Within a triangle, the line parallel to one side intersects the other two sides. The triangle formed in the given triangle are similar. So let's take, and then if altitude is drawn on the hypotenuse of the right triangle, the two triangles formed are similar to each other and to the given triangle. So let's see. So what's saying is lot 1 is similar to lot 2, and both of those are similar to the entire lot. Okay, the angles are all the same. It's just about now corresponding sides. So if we look at, it says determine the footage. So it says MT and MS is equal to MS and MP. So MT right here, MS is equal to MS over PT. All right. So with that said, we can set up our proportions and figure out what MT is. And you'll notice that that we have a squiggly equal sign. That means approximate. So this may have like 4 decimal places over it. They've just rounded it and they put it approximate because it isn't exact, but that's fine. I'm not going to make you put an approximate symbol for this. Yeah. So if we look at this last one here, okay, it wants AB. Okay, well, what corresponds with AB? So AB over, that's the opposite, so right here, over 15 is equal to, we could do 12 and 30, or we can do 10 and 25. I'm going to say let's do 30 and 12. So 30, 12. So if I go 15 times 30, so remember, I'm going to bring that up. So it's going to look like 15 times 30 over 12. I'm going to plug that in my handy dandy calculator. 15 times 30 divided by 12, 37.5. Now, if I set it up using the other side, so that would be, again, I'd have to use the 15. I'm just going to set up the, all right. And then I'm going to use the 10 and the 25. 10 is going to be on the bottom. times 25. That also equals 37.5. So either way you cut it, it works. All right. So I hope this makes sense. If you have questions, email me, call me, text me, whatever, and we'll figure it out.